In 1900, sponge divers hauled a corroded lump of bronze from a shipwreck off the Greek coast. Locked inside were roughly 30 precision-cut gears, machined from a uniform alloy, forming a mechanical computer that could predict celestial cycles 2,000 years before anything like it should exist. It was impossible, and it was only the beginning. Across 5 ancient shipwrecks, from the Mediterranean to the Black Sea to the Indian Ocean, scientists keep finding evidence that defies accepted history. Impossible dates. Unknown construction. Trade networks no one can account for. Something fundamental is missing from the timeline we've been taught. A tangled mass of bronze, greened by centuries underwater, glinted in the sunlight as the divers surfaced off Antikythera Island in the spring of 1900. Salt stung their faces, but their eyes were fixed on the strange object they had wrestled from the seabed, something that looked nothing like any statue, anchor, or amphora from the wreck below. Word spread quickly through the tiny Greek port. The sponge divers had found more than sponges. Local officials arrived, then archaeologists, each drawn by rumors of a shipwreck loaded with ancient cargo and a mysterious device. The wreck itself rested nearly 50 meters below, half buried in the rocky slope. Over the next weeks, teams hauled up fragments, marble limbs, bronze statues, battered pottery, and among them, the heavy corroded lump that would later reveal dozens of precision-cut gears. At first, no one could make sense of the twisted metal. It was dismissed as debris, perhaps the remains of a forgotten sculpture. Yet the artifact's regular shapes and interlocking teeth hinted at a purpose beyond decoration. The divers' logbooks record the moment the mechanism first broke the surface, April 1900. Its gears frozen together, the dials obscured by centuries of mineral growth. Even before the scientific world took notice, the artifact's presence challenged every assumption about what ancient mariners could build or carry. Why would a merchant ship, sailing the Mediterranean 2,000 years ago, be transporting a machine more complex than anything described in classical texts? Each fragment raised new questions, and none of the early experts could offer a satisfying answer. The enigma, it seemed, was only beginning to unfold. Gear teeth, frozen in mineral crust, began to reveal their secrets only after decades of careful study. In the early 21st century, computed tomography, CT scanning, brought the corroded fragments of the Antikythera mechanism into sharp relief. What emerged was a lattice of bronze gears, some as fine as a modern wristwatch, others spanning several centimeters, all machined with a precision that should have been impossible for the ancient world. Dr. Maria Glick, leading the ESAG project, mapped the internal architecture and identified 4 main gear trains, each calibrated to astronomical cycles. The Metonic train, for example, tracked the 19-year lunar cycle with a gear ratio of 223 to 19. These numbers match the mathematics of Hellenistic astronomy, but they demand engineering far beyond anything previously known from the era. Material analysis deepened the puzzle. Every gear, pin, and axle was cast from a single batch of copper-tin alloy, with uniform trace elements pointing to a single workshop origin. No evidence of repair or later modification has ever been found. Metallurgists confirmed a consistent alloy composition. It was about 90% copper, 9% tin, and traces of lead, identical across all components, ruling out later additions or patchwork assembly. Radiocarbon dating of the wooden box returned a range of 140 BC to 60 BC, yet the complexity of the mechanism predates any known mechanical clock by nearly 2,000 years. How did ancient craftsmen achieve such accuracy without lathes or precision tools? Why does no written record describe this level of technology? Dr. Glick's team reconstructed the device's function virtually, proving it could model eclipses and planetary motion with an error margin of just 1 hour over 200 years. The implications are staggering. Did a lost tradition of scientific knowledge vanish with this single shipwreck? Or is this an outlier, a glimpse into an undocumented chapter of human ingenuity? As the last gear was mapped, the boundaries of accepted history stretched thin. The Antikythera mechanism stands as a challenge to every timeline and every assumption about what ancient mariners could build or understand. And just beyond this technical marvel, another enigma waits. It will force a new look at the economic networks of the ancient world. Sunlight filters through turquoise water, catching the edges of something unexpected. A mound of copper ingots, green with age, stacked like puzzle pieces across the Uluburun wreck site. Divers moving through the silt reveal row after row of oxhide-shaped bars, 317 in total, each weighing close to 30 kilograms. The sheer scale is staggering. But the cargo does not end with raw materials. Mixed among the metal are fragments of cobalt blue glass, amber beads from the Baltic, and a scattering of gold and electrum jewelry, more than 20 beads and 12 silver ingots, each piece crafted in styles that span the Mediterranean and beyond. One pomegranate-shaped weight, made of copper and used for cargo accounting, hints at a merchant's careful record-keeping. Amphorae crowd the hold, more than 150 vessels bearing Minoan and Cypriot marks, some filled with resin, others with exotic oils or preserved foodstuffs. Mycenaean swords, ivory carvings, and Egyptian faience all surface from the mud, each artifact a silent witness to a network of trade that stretches from Central Asia to the Nile. The collection is diverse. Every item catalogued on the Uluburun wreck tells a story of exchange, ambition, and movement across continents. How did such a diverse collection of goods find its way onto a single ship nearly 3,400 years ago? And what does this inventory say about the world that built and sailed her, one that may have been far more interconnected and technologically bold than anyone had imagined? The answers, it seems, may lie in the metals themselves and in the scientific tests that would soon upend every assumption about their origins. A single copper pomegranate no larger than a child's fist sits at the center of the Uluburun wreck's accounting system. Its weight, precisely standardized, matches a unit recognized from ancient Near Eastern archives. This small artifact, catalogued in Professor George F. Bass's field notebooks, is more than a curiosity. It is a key to understanding the scale of exchange that once flowed across the late Bronze Age world. Isotopic analysis of the copper ingots reveals a chemical fingerprint linking Cyprus to the Aegean, while the tin traces lead back to Central Asia. Amber beads, once thought to be Baltic exclusives, turn up alongside Egyptian faience and Mycenaean swords. Excavation records detail cargo with origins in at least 12 distinct regions, stretching from the Levant to the Balkans and beyond. The ship's manifest, reconstructed from Bass's meticulous logs, reads less like a local merchant's inventory and more like a ledger for an entire continent's commerce. What kind of network could sustain such diversity? The evidence suggests a web of trade that crossed political and linguistic boundaries, connecting craftsmen, miners, and traders over thousands of kilometers. The pomegranate weight hints at standardized accounting, perhaps accepted from Anatolia to Egypt, allowing merchants to tally cargo with a shared system. Yet no known map from the period charts these routes in full. How did these goods, raw metals, luxury glass, carved ivory, move so far, so reliably, in an age without compasses or accurate charts? The Uluburun wreck forces a reconsideration of Bronze Age connectivity. If a single ship could carry the products of so many cultures, what does that say about the shipbuilders who designed her, and the civilization that sailed her into unknown waters? The answer may lie not just in the cargo, but in the vessel's construction itself, waiting beneath layers of silt and time. 210 meters below the surface, the Black Sea holds a secret few bodies of water can match. Here, in total darkness, a wooden ship rests upright, its hull, mast, and even the delicate sweep of its rudder preserved as if centuries had barely passed. The secret lies in the chemistry of the deep. Below 150 meters, the Black Sea's waters turn hostile to life. Hydrogen sulfide saturates the depths, and oxygen falls to nearly undetectable levels. In this anoxic zone, the usual destroyers of shipwrecks, wood-boring worms, bacteria and fungi cannot survive. Instead, the ship's oak planks and choir lashings remain untouched, their fibers still visible after nearly 1,500 years. When the Black Sea Maritime Archaeology Project's remotely operated vehicle first illuminated the wreck, researchers realized they had found a time capsule. Dendrochronology on a pine beam revealed a felling date close to 590 AD, while radiocarbon analysis of the main keel timber returned a calibrated range between 530 and 620 AD. These results, checked against international calibration curves and cross-verified by 2 independent labs, left little doubt about the ship's antiquity. Laboratory tests on the sapwood's moisture content confirmed the wood had never fully dried out, preserving even the cellular structure of the original tree. What makes this preservation so extraordinary? The Black Sea's unique layering acts as a seal, trapping the ship in a chemical cocoon. No other ancient wreck has surfaced with its wooden structure so pristine, its construction details frozen in time. Could other vessels, lost to history, be waiting in these depths, perfectly intact, ready to challenge everything we think we know about ancient seafaring? The evidence from this ship forces a new question. If this vessel survived the centuries whole, what secrets does its design hold about the evolution of shipbuilding itself? Timbers curve upward from the seabed, their angles sharp and deliberate, as if a shipwright's hand still guides them from centuries past. The hull's planks, each nearly 6 centimeters thick, do not fit together with the familiar mortise and tenon joints of Mediterranean tradition. Instead, they are pierced and sewn edge to edge with choir, coconut fiber rope, threaded through hundreds of precisely drilled holes. Under magnification, the fibers remain visible, their twisted strands undisturbed by time, preserved by the Black Sea's anoxic grip. This method, known as sewn plank construction, was thought to have vanished from major shipyards by the end of the Iron Age. Yet here, in a vessel dated securely to between 530 AD and 620 AD, the technique appears not as a relic, but as a core structural principle. The seams are sealed by molten lead, poured into the stitch holes and allowed to harden, a detail unknown in any contemporary Byzantine ship. Laboratory analysis confirms the lead caulking's uniform composition, matching the hull's construction period and ruling out later repairs or contamination. The hull's geometry defies easy classification. Frames rake outward from a sharply V-shaped keel, creating a cross-section more reminiscent of early seagoing canoes than of the broad, rounded merchantman described in Byzantine sources. Hydrodynamic modeling suggests this form would have sliced through the Black Sea's unpredictable currents with unusual stability, yet no written manual or surviving treatise describes such a design. Was this a regional adaptation, a lost tradition, or something altogether stranger? Blueprints. For this kind of ship do not exist in any archive. Instead, the vessel itself stands as the only surviving evidence, a challenge to the established story of how and where ancient mariners built their ships. What other secrets lie stitched into the seams, waiting for the next sonar sweep to uncover? A sonar sweep cuts through the cold, dark waters of the Baltic Sea, tracing the outline of something immense and perfectly circular, 60 meters across and resting 90 meters down. The image, grainy and ghostly, appears on a laptop screen in the cramped cabin of a small research boat. Peter and Dennis, two recreational divers with a knack for deep water exploration, stare at the anomaly in disbelief. Their equipment is standard, their training self-taught, but the shape on their monitor seems anything but ordinary. They released the first images online in 2011. Within days, the so-called Baltic Sea anomaly explodes across forums and social media. Theories multiply: an ancient ship, a lost fortress, even a crashed spacecraft. Yet behind the viral headlines, the reality is far less clear. The only available data comes from Peter and Dennis's private side-scan sonar files. No peer-reviewed archaeological survey follows. No National Heritage Authority verifies the site. The chain of custody for the original recordings remains untraced, and the raw data is never submitted for independent analysis. Skeptics point out that the Baltic seabed is littered with glacial erratics, strange rock formations left by retreating ice sheets. Without stratigraphic excavation or material samples, the anomaly could be nothing more than a geological curiosity. Still, the secrecy surrounding the data fuels speculation. Why withhold the sonar logs? Why avoid collaboration with academic teams? Each unanswered question chips away at the credibility of the discovery, casting a long shadow over every sensational claim. In the world of unexplained shipwrecks, the Baltic Sea anomaly stands apart, not for what it reveals, but for what remains hidden. Until the data is open to scrutiny, the mystery lingers, caught somewhere between scientific possibility and digital legend. A jagged line appears on a sonar screen, stretching nearly 30 meters along the Indian Ocean floor. The formation is too straight, too regular to be dismissed as a natural ridge. In 2022, a team from the University of Colombo announced what they called a megalithic vessel, an alleged stone-built ship off the coast of Sri Lanka. The claim, bold in its scope, sent ripples through both academic circles and alternative history forums. If true, a stone hull of this size would rewrite the story of ancient navigation, suggesting engineering far beyond anything previously documented in the region or era. Yet, for all the headlines, the evidence remains elusive. No sediment cores have been extracted from beneath the formation. No radiometric dates have been published. The only documentation comes from a single survey report by Professor Ananda Pereira, which describes the structure as a linear arrangement of boulders with no visible fastenings or ballast. Photographs are absent from the public record. Requests for raw sonar files or stratigraphic data have gone unanswered. Without these, the stone hull exists more as a rumor than a confirmed discovery. Skeptics point to the geology of Sri Lanka's coastal shelf, where ancient riverbeds and tectonic fractures can mimic artificial patterns. Without laboratory analysis or peer-reviewed excavation, the line between artifact and accident remains blurred. Professor Pereira's name surfaces in conference programs, but not in any published journal article on the subject. The absence of primary data leaves a vacuum, filled quickly by speculation. Could this be the work of an unknown civilization, or simply a quirk of nature misread by eager eyes? The only certainty is uncertainty itself, a gap in the record that demands further fieldwork before any sweeping conclusions can be drawn. The spectrum stretches wide, from data-rich shipwrecks mapped in 3 dimensions to claims like the Sri Lanka stone vessel, built on suggestion rather than substance. Each case, whether grounded in evidence or floating on rumor, asks the same question: how much do we really know about the ships that once crossed the world's oldest seas? 5 discoveries, 5 riddles, each one a piece that refuses to fit the accepted puzzle of ancient seafaring. A bronze machine, silent and corroded, suggests a level of precision engineering lost to the written record. A cargo hold packed with metals and treasures from 12 distant cultures points to a network of trade that stretches the boundaries of what was thought possible for the Bronze Age. A perfectly preserved wooden hull, sewn with ancient fiber and sealed in lead, emerges from the Black Sea depths, its construction at odds with the textbooks on Byzantine technology. In the Baltic, a circular formation on the seafloor ignites debate, artifact or accident of nature. And off Sri Lanka, a line of boulders rumored to be a stone ship hovers at the edge of science and speculation, with no data to confirm or deny its existence. Each case brings a different kind of anomaly: device, cargo, craft, circle, stone. Together, they form a pattern of contradiction. Dating methods such as radiocarbon, dendrochronology, and thermoluminescence sometimes agree and sometimes collide, producing timelines that overlap or defy artifact typology. Materials appear out of place, technologies seem unearned, and trade routes cross continents long before written maps. Even the best documented wrecks, scrutinized by teams of experts, leave gaps that peer review cannot close. The less substantiated claims, fueled by viral images and missing data, widen the gulf between skepticism and belief. Are these the scattered traces of lost civilizations, or the result of natural forces and human error? Do these ships hint at forgotten chapters in the story of human ingenuity, or simply expose the limits of our current understanding? The evidence resists easy answers. For every explanation, a new question rises from the depths, waiting for the next diver, the next scan, the next revelation. The sea, it seems, still keeps its secrets. Today, each unexplained hull resting on the seafloor is a silent rebuke to what we think we know. As new technologies probe deeper, even more anomalies emerge, outpacing the pace of consensus. The boundaries of human achievement, and the stories of those who crossed them, remain unsettled. Until science embraces the unknown, history's greatest voyages might still lie just out of reach. What do you make of these enigmas? Let's discuss below.